Okay, so welcome everyone to this webinar on making catchment data more accessible to end users, which is part of the Catchment Data and Evidence Forum this week. If I could just ask everybody to make sure their videos are off and their mics are on mute while we're on the webinar, because we're using Zoom meeting for this one. And we're really pleased to welcome Matt Fry, who's the Environmental Informatics Manager at UKCH, who's going to tell us a little bit more about some of the data tools and resources that they've been developing to help make data more accessible, including sort of using APIs and web platforms to access and integrate data. As Matt's presenting, if you want to post any questions in the chat, we'll then have a Q&A session towards the end. So I'll now hand you over to Matt to tell us more about it all.
Thanks very much, Lucy, and yeah, thanks for the opportunity to speak to everyone today. It's quite nice, because probably looking at the names, it's not necessarily the same audience that I regularly talk to, so it's good to get a chance to talk to some new people, but bear in mind you might all have specific types of interest, and hopefully there's time at the end to ask specific questions. So if I'm not giving you the information you need, please feel free to ask for some more details at the end. So I'm just going to try and share my screen. My name is Matt Fry. I'm from UK Centre for Ecology and Hydrology, and I'm going to talk today a bit about making catchment data more accessible to end users. Now, normally we have quite a range of different end users, often in the research area, but we're generally trying to focus make sure that the work we're doing can have kind of impact outside of research as well, and make that data available more widely, and make sure there are tools in place to make sure people can access and use that data. So I'm going to be talking about a range of different projects and different kind of outputs, which where we've tried to sort of take these different things forwards, and how we're trying to bring these things together to deliver data. This is work on behalf of a huge range of people at CEH, listed there. So I've got a sort of team of people work with me on data systems, so producing data sets, analyzing data sets, kind of making data sets available over the web. And I'll talk about some of those projects. So yeah, thanks to everybody involved for this. So in particular, I'll be talking about data availability generally, hopefully giving you some information that's useful for you in your work, but you can ask me questions at the end to make sure it's as useful as possible. Like I said, a lot of that work is on making the data that's available both across the UK and from research more accessible for researchers, so that it kind of underpins new analysis. But also we're trying to make the research data that's produced more accessible in general. So we do a lot of work in research areas producing data sets that are useful for research themselves, but we know they've got more widely useful range of uses. So we're trying to get those things out there and make them get more impact from the research data, and also not just plain data sets, but kind of delivering that data in ways that can make it directly useful. Just keeping an eye on the time so that I know where I am. So my role is in the Water Resources Systems group. So I'm primarily focused on hydrological data, have been for a long time, but increasingly we've been looking at water quality, other freshwater data, and in particular the kind of integration of those aspects of data and how we make them available alongside each other. And this is often leading to things like APIs, and I'll explain a little bit about that in a minute if you're not familiar with that term, and data portals, to try to make that data accessible to a range of people. So just to run through about APIs, I know they've been mentioned this week, and there's been some fantastic discussions around data sets I'd never heard of or wasn't aware of, and APIs that are being produced to access them. So this is application programming interfaces, and it's basically accessing data over the web from some computer program. So they give you the opportunity to query data sets over the web, and they can give these benefits of making data more dynamically accessible, rather than downloading huge amounts of data and storing it locally. You can actually get updated data much more rapidly, or plug in the work that you're doing to data sets that are kind of dynamically updated it can lead to kind of potentially simpler integration of data from different sources. And I'll put a question mark in there because obviously there's a level of complexity when having to build kind of programming systems to access these data sets. But overall, if these things are structured properly, they can enable this integration of data from lots of different sources much more readily and much in real time. They can avoid people having to download and store large data sets locally on your computers or on your, say your work servers. If the data, the data is hosted somewhere else and it's very big, you can just pull out the data, the parts of the data that you want. It can avoid issues like managing files and versions of that data. If that data is updated at a later date, you can always be going to the source of the data and getting the data that you want. And it can, if it's structured properly as well, enable, make sure that the provenance of that data is clearer, both in terms of the metadata being with the data itself, saying how that's produced, but also making sure that you're accessing a specific version of that data rather than, people having files that are from different times and causing confusion about things there. So in the longer term, that's hopefully going to lead to better, more reproducible science. So just taking the areas of work that I work in. So one of the things I've been involved in for a number of years is the National River Flow Archive, and you might be fully aware of this data, so I won't dwell on it for too long. But basically, we've been trying to, there's a fantastic measurement of river flow data in across the UK. It's increasingly accessible, but in the past, it wasn't necessarily readily accessible. So we've been kind of trying to curate that river flow data across the whole of the UK from different measuring organisations for a number of years, and making sure that was appropriate to deliver to kind of the research, but also wider communities. And there's say around 1,500 flow gauging stations around the UK with data from the 1880s onwards, and we deliver this data via a kind of website with tools for searching for stations and enabling the kind of download of data files via kind of CSV files, for example, for flows or catchment average rainfall for gauging station catchments. So it's a kind of really useful resource, I hope, for river flow data across the UK. So we have these kind of search tools that should make it easy to find stations of interest, either within your catchment that you're working on or across, broadly find stations of with particular kind of soils or land cover. So we create a kind of huge range of metadata about the catchments as well. And we have these range of pages which both talk about the detail of the gauging stations, about how the flows are measured there, some statistics on the flow data, statistics on the catchment information, and we provide catchment boundaries as shape files and like I said, downloads of flow data and catchment rainfall data from those things. So recently we've moved away from having, well, we've still got CSV downloads for people who want that, but we've introduced this API for batch queries of the data to enable people to more rapidly access the data. I'm just going to kind of run through what that looks like. So the NRFA API is very simple, and it's kind of, we try to keep it simple and make sure that we can kind of support it going forwards. So it gives people direct access to the data. They can query for a list of stations, query for a time series, so whether it's flows or catchment rainfall, or say the flood peaks for a station, and then they can query for catchment information, so that's metadata and land cover, geology, etc. for the catchment. So you can request data in different formats, and this API now is forming the basis of how we deliver our data, both to our website and also to things like, there's an NRFA package which has been developed by somebody else, which is quite popular now in research. So it embeds that data access into some statistical functionality for processing river flow data specifically. So it's quite a nice demonstration of how, by moving away from just providing files of data, we can kind of embed that data into sort of research tools. So there's the URL right at the bottom there, if you can see that. I'm just going to kind of run through what those sort of queries look like for those of you who may not be aware of this sort of thing. So here's an example kind of query at the top, this URL, and it's broken up into the main kind of part of the URL, something that says, well, a number of parameters at the end here. So the first one just says this is the time point for getting the time series data. And then there are a number of parts where you can specify the format, specify the data type, which we define a thing called the data type, which is, say, the catchment daily rainfall or the daily flow data. And then you can specify a station or a list of stations at the bottom. So that basically defines the query that you want, and you put that URL into a search engine, into a browser, or call it from your program, and you'll get back a data file in this format. So there's other types of formats that are potentially more useful for programmers, but it's possible to specify a number of things, and you get data back in this format. So it's quite, we try to keep it quite simple, make it easy for people to understand how to call it, and it's, yeah, like I said, it's kind of widely used already. So it now kind of accounts for quite a significant proportion of the uses of NRFA data. Like I said, it's used in our website here to deliver data alongside real-time data. So we get more than 500,000 queries to the API last year, more than 270,000 time series queries so far this year. That RNFA package is popular as well. Like I said, it's had more than 20,000 downloads, so it's really driving a big use of this sort of data, which is great. And it drives our NFA website and the water resources portal, which I'm going to speak about in a minute. So that's just an example of some of the data we're making available that hopefully is useful, but like I said, you might be aware of it already. So I'll talk about a few other examples now. So one thing was that Lucy asked me to talk about this CAMELS GB dataset, and I know that Gemma Coxon spoke to this forum last year, but I think this dataset wasn't released at that point. It's now been publicly released with an open license, and this is basically so CAMELS is a kind of what they call a large sample dataset. So it's kind of trying to provide flow data with a range of enhanced other attributes to the data, pre-packaged up to make it easy for doing an analysis across a large range of stations. So it's got it's NRFA data, but it's got those, which itself is data from the EA and SEPA and NRW, but it's a standardized period. It's got a kind of a wide range of catchment characteristics in there, some additional ones to the ones we normally store on the NRFA. I should say at this point, this has been driven by Gemma Coxon from University of Bristol, but with contributions from ourselves and a range of other people. It comes with a huge range of daily MET variables, including potential evaporation data for all of those stations for that time period. It's also got some measures of artificial influence, so it's a mean daily abstraction and discharge volume for each of those gauging stations, for stations in England, I should say, based on the actual recent abstraction data that they were had access to. So they've kind of processed that data up to give a mean daily abstraction discharge level for those stations. And that data set, you can now download that from the Environmental Information Data Center, and there's a data paper on it as well describing the data set in detail if you want to know more about that. So that's, like I said, I suppose it's primarily designed for researchers doing analysis across, the wide range of catchments in the UK to understand, like these images at the bottom here, to understand the differences between catchments in particular areas, or what's driving certain aspects of river flow data. So I mentioned a moment ago our water resources portal. So this is a new a kind of bit of work that's come from a big drought program that we've had for the last few years, finished last year. And it's delivering basically real-time or near real-time data, or as real-time as we can get it, data on a range of aspects of water resources for stations across the UK. So it's got national coverage, but you can actually get very local scale data in there, and it integrates near real-time, say, daily flow data from the Environment Agency. They've done a fantastic effort of making their river flow data available in real time via an API, but it potentially makes that data from that API really useful because it provides the historical context, as you can see in these top plots on the top right here. It provides these bands which are kind of standardized against the EA approach for producing these, for reporting on, to say whether that day's flow is low or medium or high in the kind of context of the long-term flows at that site. So it integrates, it gives you that real-time data, the EA flow data is available in near real time, so it's usually a couple of days until it's available on there. But we also get monthly data, provisional data from the Met Office, and we produce that across this range of both gauge catchments, but also a range of kind of generic kind of catchments, say the whole of the Thames or subsets of major basins, and we can plot the rainfall data alongside the flow data. We also have things like the Cosmos soil moisture data, which is real time, and then a kind of monthly updated groundwater levels and a similar kind of standardization of those historical context. So it's really useful for providing, both as well as providing that real-time data, it provides this kind of context at the national scale, and you can kind of understand whether it's high flow events or there's a whole range of options for looking at the data, the actual, say, flow data as a standardized drought indicator, something like the SSI and the SBI for rainfall data. So it enables the kind of standardization of those data sets for comparison across the country. I could talk about this for quite a long time, but the link is here, but there's also a recent CABA water resources workshop, which might be the best place to kind of understand it in more detail, where it's presented in detail and discussed. And there's a link to the YouTube video for that workshop at the bottom there. So one of the other things I want to talk about was this catchment rainfall data. So like I said, we produce catchment rainfall data for the gauging stations and for the water resources portal for some other kind of general large catchments. And we do that from Met Office sources, and at the moment we're producing this gridded daily 1 kilometer data set based on all of the available rain gauges across the UK, and producing this gridded data set and making that publicly and openly available, kind of updating that on a roughly annual basis. It takes some time for us to get the kind of not the provisional data, but the kind of finalized rain gauge data, and then we have to work to build up these gridded products. So we update it roughly annually, but there's a bit of a delay each year. So it's currently been updated up to 2017. We're hoping to update that again soon. We've also recently produced, working with a group from Newcastle University, an hourly version of this gear data. So it takes the hourly rain gauge data or sub-daily data from the agencies and distributes that daily rainfall across the day in order to give this hourly product. And that's available at the moment from 1990, which, you know, before that date there weren't sufficient sub-daily gauges in operation to do this, and it's up to 2014 at the moment, but we're updating that at the moment to the same period as the daily data, 2017. So like I said, we provide some of these catchment rainfall series for existing predefined catchments that we make a lot of use of, but we know that many users want this kind of data for either individual locations or one of those points on that maps just for a particular bit of work, or for bespoke catchments that they're working on, or other kind of non-river catchment areas. And it's, whilst that, you know, the data basically enables that to happen, it's potentially quite a complex thing to do if you don't have a lot of technical skills. And the data sets themselves are large. So if you wanted to download this daily gear data set, it's a huge thing. And that in itself can cause a lot of problems. So we're trying to think about how we can build these tools through APIs and other things to make that more readily accessible for people. So, like I said, recently been working on this program called the UK Drought and Water Scarcity Programme. And within that, we've tried to collate a lot of the data sets, which are UK scale hydrological data sets, and make sure they're as useful as possible to end users. So this provides a range of kind of both descriptions of the data sets, but also kind of interactive tools for extracting bits of the data. So a kind of point and click for a point here, or you can upload a shapefile and it calculates the average rainfall over a catchment that you've uploaded yourself. It's also got some of these drought statistics data sets, which are similarly large gridded data sets. And it's got other things in there like long-term modeled flows from a model called Grid to Grid from CEH, either at daily data at gauging stations or monthly data for lots of other points, or all other points on the 1 kilometre grid across the UK for a kind of particular period. In there, and if you go to that link, you'll also see there are some kind of future climate scenarios for flows and soil moisture from one of the projects in this drought programme. I've spelled weather wrongly there, haven't I? Weather at home. It should be the other weather. So I'm just going to show how that works. Sorry, by going live to this one. So this is what this drought data hub looks like. It provides, like I said, a range of kind of information on lots of these data sets. You can browse through the data sets and try and understand what they look like. Whether it's grids of these SPI data or these modeled historic flows, and the CEH gear is this rainfall data I mentioned. So there's gridded data sets and point data sets that you can find out where the data is by looking on the map and then extract certain parts of the data. But particularly, I know of interest is this aspect of uploading a particular catchment of interest. So we can find this data set and add it to the map here, and it kind of gives us a brief preview of what that looks like over the UK, and you'll see the kind of 1 kilometre gridded resolution as we zoom in. And you can either kind of pick a particular grid cell where you're interested in extracting data, or you can go to this access the data area, choose to upload a shapefile, choose the date range you're interested in. We've broken this up into different chunks here because it can take quite a long time to process. And then you can choose a shapefile to upload, and you have to upload this as a zip file. So if you make a zip file with the separate parts of your shapefile in it, it can use that to understand. Hopefully, here's one I prepared earlier. I can't see that there. So it first shows you where that catchment is that you uploaded. This is one in the northwest, and then we can click to fetch the data. So yeah, it gives you a preview of where that catchment is, and it's basically sending that shapefile up onto the CH servers and going through that big gridded data set. And for each time slice in that data set, it's getting the grid cells that fall within that shapefile boundary, and it takes an average of the values for each day from those grid cells to produce a kind of like a 50-year time series in this case. So it comes back, it's like I said, it takes a bit of time. It might take kind of 20 seconds, 30 seconds to do that processing, because it's quite a kind of intensive job, and it passes back the rainfall data set that you can then download as a CSV file. So this is an attempt to just to understand, or we know that this is functionality that is really widely of interest out there, and it's an attempt to try to make that available. It's not, I can't say for sure that it's something that we'll do for the next 20 years, but it's definitely the sort of thing we're trying to do, and we want to get feedback from people on how useful this is, what other aspects of it, or whether it's, if that's what type of processing they want to do, if are people interested in just using single grid cells, or a catchment at a time, or do they have 10 catchments they're interested in? And I don't think it would necessarily be that useful for doing hundreds and hundreds of catchments across the UK. There might be other options for doing that sort of thing. So that's one of the key things I wanted to show today, and I'd be interested to get feedback on how useful people think that is. But it should be useful if you've got shape files for catchments in areas that you work. You can try this out to get, like I said, rainfall series for them. But you'll see that this is at the moment, this only is for the gear data set up to 2015, and if we haven't yet updated it to the 2017 version, obviously it doesn't go right up to the present day, so it doesn't necessarily answer all the things that people will need from this. But and you're welcome to explore some of these other tools in there. So the next thing I think what I was going to talk about is work in a project called UKscape, which is a big UK CH science program, which kind of delivers a lot of the work that you might be familiar with, things like the land cover map, the National River Flow Archive. Lots of our monitoring is grouped in this science program. But there's a significant element in this program, UKscape, on improving the way to deliver research data and deliver kind of informatics and data science and deliver data into those things. And APIs in particular have been identified as a kind of key element of how we make our data resources more accessible I think I have to say it's primarily for researchers, but at the same time is making them useful more widely than that. So as part of this, we're trying to understand what is needed from these APIs. There are very different ways that you can set these things up. So we've built this demonstrator portal for hydrological data that's built on an API, and we're trying to look at how we can integrate real-time data in the first instance from a range of different public APIs to understand how to integrate things. So there's, say, SEPA rainfall data. You can see on this top picture here, rainfall data available in real time from SEPA and the Environment Agency, each from their own APIs, which you have to query in quite different ways, and they potentially give back slightly different information. So we're trying to work out, or we basically built a kind of middle layer to see if you can query these things in a consistent way, sort of send one set of queries and get the same data back, or get data back from both organizations. So as well as that focus on the real-time data, we've been looking at the Environment Agency Water Quality API, the WIMS data, or the Open Water Quality API, which I know there are a lot of tools in some of the CABA tools as well, which allow you to do kind of detailed access to some of this data. So it's worth looking at those as well. But this, we've been trying to understand, in particular, how you enable more kind of comprehensive kind of data discovery queries to find relevant sampling sites. And like I said, trying to understand user requirements for these sort of APIs. So again, I'll show you what that looks like in a moment. But yeah, in terms of the water quality, we've been particularly thinking about these data discovery queries. It's a fantastic resource, this EA API, and it's amazing that it's really impressive what they've done in terms of the push for open data recently, making this stuff available. But it puts the data out there so people can access it and do what they want with it, which is fantastic. Currently, the kind of interface and the query mechanism that they've got on top of that, you can just download everything and do what you want with it, which is great. But the interface that they've got is focused on a kind of site-by-site interactions, what's measured near me, and then you can go into that site and understand which determinants are measured and how much data there are for them. But quite often we get in discussions with people at CEH and more widely from a research point of view, people wanting to find sites across whole catchments or whole areas or whole of the UK, trying to understand which sites have got enough data of these particular determinants to do analysis with. So they don't want all of the data from all the sites because some of them won't be any use to them. But you can't necessarily do those queries directly from the EA API. So we've put a bit of work in to kind of pull that data down and summarize it and aggregate it and enable those kinds of queries. And other people might want to there are things that you could do to visualize this data across the catchments, which you can't necessarily do in the EA interface, such as show all the sites that have got lots of determinants measured, so you can pick out the ones that are going to likely to have the stuff that you're interested in, or show sites with lots of measurements for your determinant of interest, or show, say, the summary information like the long-term mean or potentially trends for sites across catchments. So we're trying to see what you'd need to do to these APIs to kind of enable that extra level of access, which we think is kind of critical for in particular for this kind of research questions. But it's not, I don't think it's particularly just research, it's probably more widely useful for people. So just to show you what that looks like, like I said, we've got layers in here for Met Office and SEPA and EA rainfall data, but I'm going to focus on the water quality data. So at the moment you can choose a whole kind of catchment or hydrometric area, and it finds all the sites across that area kind of immediately, and it highlights them. It gives you a bit of summary information when you hover over them about how many determinants are measured, how many measurements there are, the dates at which that spans. So it's kind of summary information, and it's giving the size of those points based on the number of determinants there. And you can kind of filter those out just to show those with lots of determinants, say, for example, if that's of interest to you. We can choose a particular site, and then it just goes straight to the EA API. It's not actually doing anything different here. It's just helping to display the data on there. So it shows you all the measurements at that particular site and lets you plot that data up. And it might be this site hasn't got a lot of data, but it just pulls that data straight from the EA API and does a bit of a graph. So it helps you kind of visualize the data as well before you might want to download it. But in particular, we've got these functionality to filter the sites across the kind of that area by selecting determinants of interest, and we've got some of the kind of most heavily used data here. And I should say this has been filtered on just the freshwater sites, so it's none of the kind of coastal or estuary, groundwater or kind of sewage effluent data. But if we choose a kind of phosphorus measure, we can plot that data on the map. So we're just showing sites that have got phosphorus data, and with the size of these blobs showing the number of measurements at those sites. So you can immediately find the site in your river which has got the most measurements that might give you the most indicative information over a kind of longer term. And it's really interesting to look at the kind of trends in decreasing phosphorus over recent years. And like I said before, we could potentially pre-process this data to kind of summarize this sort of trend information and show that on a map, which might be useful. We haven't got that far yet. So one of the useful things you could do is also plot, either show these by, this is by the number of measurements, or this is the mean measurement. So you can immediately highlight, whilst it might be completely overridden by a couple of spurious, very high measurements, but it should give you an idea of where particularly high measurements of any of these determinants are across a catchment or across a number of catchments, and allow you just to kind of quickly dig into that data to have a look to see what it looks like. And you can do that for multiple determinants. You can filter where there's phosphorus and say, I don't know which is the best nitrogen determinant to use, because they've got different very different numbers of measures in. But you can so this is sites where you've got both at least 100 nitrate as N, and you can combine these queries to say multiple determinants. So find sites that have got both of these determinants or a longer list of determinants, and then drill into that data to see what it looks like. You can also kind of just filter out the sites that have got a certain have got sufficient number of those measurements, just to see the sites that have definitely got a range of a decent number of measurements over the period that's specified. And you can specify the start and end period of which you're querying as well. So it's not doing a huge amount extra. All the data is coming from that EA API. It's just that we've kind of pre-processed some of that to give this information to allow us to do these kind of filters. So again, it's very much a kind of demonstrator tool, and we're trying to understand, does this deliver the kind of functionality that makes this data more useful? Does it enable the kind of queries that people want, like I said, particularly for research, but for other users as well? So any feedback is really, really welcome, particularly from kind of groups that we don't necessarily get that much interaction with very often. And like I said, I know you can do more complex queries on the EA WIMS data, including downloading the data, which you can't do directly from here through the Cabba tools. Sorry, I need to move this out of the way now so that I can get back to the presentation. So just very briefly on some upcoming work. So in the UK, this might be of interest to some of you for longer term. UKscape's also developing what they're calling data labs, which are these kind of collaborative cloud computing spaces for running analyses against large data sets. So there may be situations where API access to data is not kind of sufficient to run an analysis, to pull all of this data across over an API, but it allows us to create a space on the cloud where people can log into it and write and run and share analyses in code, for example, in these Python and R notebooks that there's an example of in the bottom corner here, that can access that data very quickly, can kind of get the benefits of that sort of cloud computing, like large scale analysis, and you can kind of enhance code. We could provide example code and people can enhance that code. So again, it does have a bit of a research focus, but it may be somewhere it may be a potentially good avenue for sharing access to very large data sets in future. And this point at the bottom, so we're using this data labs technology in a project called Hydrojoules, within which we're downscaling UK CP18 data to and then running it through hydrological models. So it's likely, we hope, that there will be kind of modeled future river flow information coming from some of these projects and delivered in this way in future. And these, obviously, you can imagine these are huge data sets. When you start looking at data 100 years into the future, the idea of downloading them just becomes an impossibility. So this is a kind of potential solution to allow access to those things. And one very last thing is just a wider point I want to make about really fully exploiting all of this river data. There's a huge amount of data that things that I haven't heard of before over the last few days, and a huge amount of efforts to link these things up. And I'm very much, I want to make sure that we're not trying to kind of add to potential overload of portals with these things, but we do want to work towards, producing these APIs that other people can integrate into the work that they're doing, into their own websites or portals and things like that. But a key aspect of this, I think, is going to be making sure we exploit the linkages along the river network between these data sets. So linking monitoring data to things like background catchment information like soils, land cover, topography, but also these kind of drivers of whether it's water quality or other aspects of river health, sewage treatment works, sewage overflows, it could be field scale, crop cover. There's huge amounts of data out there, and if we want to really get the most of it from these data-driven, AI or statistical approaches, we need to really work on linking this data up. And this is something we've been working on in a project called InTrain and this NERC Digital Environment program, trying to describe what you would need to do to produce this kind of digital spatial data sets that allow us to link together lots of these monitoring data sets. So in particular, we've been matching these EA WIMS sites to the 1 to 50,000 river network and building a set of tools that allow you to kind of find everything upstream, find everything downstream, and link monitoring sites with either with other monitoring sites, complementary data, or kind of upstream drivers of water quality and things. So that's another aspect I think is really crucial in future. So that was the last thing I wanted to say. Sorry to overrun slightly, but thanks very much. Yeah, and if anything I've said is of interest here and I don't have a chance to answer the questions, please get in touch and ask me directly.
Okay, thanks for that, Matt. I think you've probably blown everybody's mind with all that data and information that's available. It's absolutely fantastic. And there's a few comments from people in the chat, particularly saying that the improved ability to query WIMS data and the improved viewers, fantastically helpful for people. We've got one question from Catherine, who's just mentioned about the CH Lakes portal as being a really useful resource. So I don't know if you want to just mention that quickly, but she's also asked if there's any plans to be able to make the data from that portal available to download as shapefiles or in ArcGIS online.
Yeah, sorry, I didn't talk about the lakes file. I know it was down on the agenda, wasn't it? That's very bad of me. Yeah, so we worked on that a few years ago to produce that portal, and it was a long time in getting agreement to share the data in that sense. And I suppose firstly, yeah, to mention the portal, we put quite a lot of work in this aspect of linking data between different data sets is kind of key to that. So one of the things which is of interest is the BRC biological recording data. We put in the lakes layer into there so that we could identify freshwater species that are actually located in those lakes, and also from the recording side of things, enabling people doing species recording to tag a record with a specific lake by those lakes water body IDs. So that kind of much more directly links the species monitoring to the lakes, rather than just being in a kind of a grid box, which may or may not overlap with a lake, or may overlap with two lakes if it happens to be in a particular position. So that, yeah, that was, I mean, I'm glad that's useful. I think the group, so that's run out of the group in CEH Edinburgh, and I work with them quite closely, and I think they are keen on trying to make that more open, and in the process of discussing that. That's probably as much as I can say without saying anything that's probably, I might get the wrong end of the stick, but I think that is an aspiration, and I'd hope it's coming along at some point.
Okay, that's maybe something we could follow up.
Yeah.
And James Gilbert said he's got a question on flows in headwaters if there's time. So I'll maybe just find you, James. if you unmute yourself and want to ask it.
Yeah, firstly, just Matt, thank you so much for that presentation. That was really, really interesting, and I know it's very geeky, but it's all very exciting for me, at least.
Great.
One question, when dealing with the regulated water, one of the tools that we quite often use is Sagis, and quite often I find myself sense checking that. And sometimes there's issues with the flows in headwaters, and that's usually derived by the fact that there is limited monitoring in headwaters. Now, when I see that you've got the ability to map out the rainfall in a catchment leading to a flow gauge, and I know that the portal also gives you information on land cover and geology, etc., etc. And I'm an environmental scientist, I'm not a hydrologist, so this might be a complete wacky idea, but would there be any way of apportioning that flow out into the smaller reaches up catchment, as it were?
Yeah, I suppose you could do it that way by linking it to the rainfall, and then, or just distributing the flow by catchment area, say. But I suppose another option which would be of interest is to try to integrate modelled flows. Like I said, about in that drought data portal, we've got historic modelled flows, and it's on a 1 kilometre grid, but it would give that sort of data gives an idea of gives you a time series, a daily flow or monthly flow time series for points away from gauging stations. So it should give you an idea.
What was that data set, sorry?
So in the drought data hub that I mentioned, and I can follow up with a link if you like, there is a gridded modelled flow data set from the grid to grid model of from say 1960 to 2015 or something like that. So it's not, again, it's not real time, but it should give you, at least at the monthly resolution, some estimate of how, well, of the way that those flows have been modelled. And there's obviously caveats around what particular models are good and bad at, in terms of they represent very small catchments, headwaters in particular. But that might be a starting point. But
I think the model behind Sagis is low flows 2000.
Yeah, which would, in terms of the long-term flows, and certainly something that's consistent with what the agency kind of would use at a particular point, would probably be the way to do things. But, it depends on what your particular application or interest is, I guess. But there would be different ways to kind of estimate what those flows might be.
Great, thank you so much.
Okay, thanks. Can't see any other questions in the chat. Heather Bond did ask where the data comes from in UKscape. You showed us the WIMS data and the flow data, but you could also access Met Office data through there. And is the Cosmos data in there as well?
I think, I didn't show the API as well. So that was just an exercise in trying to standardize access to some of these APIs that are out there. So I should say this is just a part of UKscape. It's not like the interface to UKscape as a wider project, but it's just a particular bit of work for hydrological data, trying to demonstrate how it might make it easier to access these things by standardizing the interfaces to some of these portals. So there's EA data, there's SEPA rainfall data, there's Met Office, and I think they provide like a daily, the last 24 hours of data for their stations, or a forecast for the next week, for example. So it's just getting hold of what you can get hold of. And there's CH flow data from the NRFA in there. So it's a range of different sources in that sense.
Okay, well, thank you very much again, Matt. You've given us such a lot to think about, and lots of links for people to go away and have a look at. I've posted the links in the chat for people as you were talking, and I'm sure if people want to follow up, they can get in touch with you to ask any further questions.
Please do, yeah. Like I said, email address is there, and feel free to get in touch and ask for anything, if there's anything I haven't explained very well.
Okay, great. So thanks to Matt for sharing all that information today, and thanks to everyone else for joining and taking part. And we'll share the recording via the CABA website as soon as we can and let everybody know when that's available. So thank you. And if you're joining us for the next session on connecting communities with natural capital, we'll look forward to seeing you all again shortly. Thank you.
Thanks very much. Thanks, everyone. Bye.